Okay, so we're skipping C because it has addition, and I'll go over those rules in a second. But D doesn't, so we only have multiplication and division in this one. Okay, so one is a, oops, and I have mine written a little bit different. Mine looks like a fourth root of 11, and I should make sure that it looks like 4 square root 11, because there's a difference there. The bottom one does have a cube root. Okay, so I have division, I have no adding and subtracting, so step one is I'm going to try to vertically reduce any fractions if I can. 4 over y does not reduce, okay, so it stays the same. Now, the radicals, I would not reduce those ones. Does anybody know why I would not reduce those? Because they have different indexes, right? If they were, even if, although 11 over 6 can't reduce anyway, but if the top was 12 and the bottom was 6, I still could not reduce 12 over 6 because they have to be under the same radicals for me to do that. One's under a square root, one's under a cube root. So we can't do anything here. Horizontally, can we simplify our 11? Is there a perfect square that fits in there? No. Can we simplify our 6? Is there a perfect cube that fits into there? No. So this one, step 1 and step 2, we can't do. So step 3 we want to do. We want to rationalize the denominator. This one's a little bit different though. It's not a square root, it's a cube root. So how do you cancel a cube root? What's the opposite operation? Cubing, right? Which means times it by itself, make sure there's 3 of them. Well, there was already a cube root 6 here. I'm going to put in a second one, and then I'm going to put in a third one. And I'm going to do the same on the top, right? Because if I don't times the numerator by the same thing, then I've actually changed the value of it. Okay, on the top, what we really have is all of these items are getting multiplied together. Okay, so we can multiply all the numbers out front together. This one has a 4 out front, this one technically has a 1 and a 1. So 4 times 1 times 1 is still 4. Okay, we cannot multiply 11 by 6 by 6 because they have to be under the same radicals. So this one's going to look a little bit weird. Any square roots can get multiplied with other square roots, but we only have one. It's 11. Any cube roots can get multiplied by any other cube roots, but we do have 2 of those, so 6 times 6 would get me the 36 there. Okay, on the bottom, I'm multiplying all these things out. Okay, this one's got a y in front, this has got a 1 in front, this one's got a 1 in front, and so when I multiply all those together, this would be a y. They're all cube roots, so I can multiply them all together. 6 times cube root of 6 times cube root of 6 times cube root of 6. And I could know what 6 times 6 times 6 is. Or, what's the cube root of 6 if you're times it by itself 2 more times? Just 6, right? Because it's, I'm going to write this another way. This is the same thing. You've just cubed it, right? So now what happens is the cube root and the cube cancel. So that's why you're just going to get a 6y on the bottom. Okay, so the bottom is just going to be a 6y. On the top, though, now we're going to go back to step 1. Can we vertically reduce? Oh, hang on. I'm going to rewrite it first. This is a 6y. Can we vertically reduce right now? We can. We can vertically reduce the 4 over the 6. What does it become? 2 over 3. So you have a 2 over 3. The y just stays in the denominator. Okay? And then we can look at horizontal reduction as well. Horizontal reduction is just if you have something that's under the radical that can be reduced. There's no perfect square that fits into 11, so that one stays the same. Is there a perfect cube that fits into 36? 16? Nope. 16 would fit into 32. 16 is not a perfect cube anyway, so which perfect cube fits into 36? There is one. Oh, is there? I was thinking 8, but that 8 doesn't work, does it? 8 fits into 32, but not 36. Okay, so I think that this one's done. Let me check. Yes, we can't go any further. So this is the final answer for this one. Okay, now when you look at y definitely can't be 0. Okay, because it's in the denominator. It looks like it could be positive or negative though, but I'm just going to double check from my original question. How did it look to begin with? It wasn't underneath the square root or a cube root anyway. If it was under a cube root, it really doesn't matter if it's positive or negative. If it would have been under the square root originally, I'd have to just check a few things. But this one, there's actually no restriction. It's just that y is an element of reals.